Hey, this is Andrew Brown from Exam Pro. Today is July 15th, 2020, and we're at AWS Amplify Days. And I'm giving a talk here on DynamoDB table designs for AWS Amplify. This is a level 100 introductory talk, meaning you don't need to know anything about DynamoDB. The whole point is to teach you about DynamoDB so you can get off of SQL and embrace NoSQL. And just fair warning, I'm very fast talker and I pack my slides full of information, but do not worry. I always pre-record these, so afterwards you can watch them again and again, and you don't have to worry about taking any notes. So let's move on. And before we jump into it, I just want to tell you a little bit about me. So if you want to find me, it's Andrew Brown on Twitter. I'm the CEO of Exam Pro. I'm based in Toronto, Canada. I'm very well known for my free AWS certification video courses on Free Code Camp. I'm the co-creator of the 100 Days of Cloud Community Challenge, previously the CTO of multiple startups. I'm an AWS hero, and I love watching Star Trek. And if you ever want to buy me a drink, I love coconut water. So on today's agenda for this tech talk, we are looking at some use cases as to why I'm using AWS Amplify. What is the difference between Postgres and DynamoDB? Why would you want to use AWS Amplify backed by DynamoDB? How do you use AWS Amplify with DynamoDB? And what is multi-table versus single table design? I'm not going to really be going into technical implementation. I feel like there's a lot of great tutorials out there. What I'm going to focus on is giving you that foundational knowledge so you really understand what you're doing with DynamoDB. So there are two use cases where I'm using AWS Amplify. The first is with Exam Pro, which is a brownfield project. Exam Pro is a learning platform designed to help you pass AWS certification with thousands of active users. On the other side, we have 100 Days of Cloud. So this is a new project or greenfield project. And this is a cloud community challenge to provide structure, friends, and support along your cloud journey. So on the Exam Pro side, the reason we're using it is we're moving parts of our apps over to AWS Amplify into micro frontends. For 100 Days of Cloud, we're using AWS Amplify to keep track of cloud journeyers' 100 days of progress. And the outcome, the technical outcome we want with using AWS Amplify, or at least for Exam Pro, is that we're hoping to get reduced operational maintenance, get back some of our agility, and massively scale without worry. On the 100 Days of Cloud side, because it's a new project, we want for it to be extremely cost effective. Having that highly opinionated framework, which is what AWS Amplify is really good because if you have a lot of community members, they're going to just stick to one thing. And it's designed for rapid development. So you can see it works for new and old, small and large. So AWS Amplify is really good. So what is the difference between an SQL database and a NoSQL database? Very important before we really jump into DynamoDB. So we have Postgres on the left, DynamoDB on the right, and I have 4 categories here to help you understand very quickly the difference. So queries is when you go grab your data. And so on the SQL side, you have very flexible queries, but the trade-off there is that they're expensive and they don't scale well. It might not be very obvious at the start, but as you grow, it becomes very apparent how expensive they get. On the DynamoDB side, your queries are extremely limited, but on the upside, they're very inexpensive and they scale very, very well. In terms of design, we don't have to do a lot of thinking about data access patterns and performance with SQL. We just kind of jump into it. With DynamoDB, you really have to plan what you are going to make. So you have to really think about your access patterns. You really have to think about how you're going to squeeze performance out of your table designs. For your schemas, they're very easy to modify and extend in SQL. And your schemas are going to generally be highly normalized, so table per entity. It's going to be very clear and easy to understand what's going on. For DynamoDB, you're going to tailor your schemas for the business use case, and you're not trying to change them too much. And generally, the data is better to be denormalized. So you'll have duplicate data in some tables, which can get messy if you're not well organized. But that's the difference there. So when would you use SQL versus DynamoDB? Well, the recommended use case, I would say, this is my personal opinion, is that SQL is really good for building monoliths. So if you're still an old team using monoliths, maybe you want to use SQL. If you have yet to narrow down your long-term feature sets, a lot of startups haven't. So that might be another reason. If you have an unstable business model or scaling isolation is not a priority. For DynamoDB, if you're building micro frontends or microservices, DynamoDB is a really good fit. If you've narrowed down your long-term feature set, if you have a well-defined business model that's working for you and your priority is now scaling isolation, the DynamoDB is really, really good. So why would we want to use DynamoDB? All right, so we did the comparison, but let's talk a little bit more about DynamoDB in specific. So DynamoDB is it's low maintenance at scale. So what do I mean by that? Well, since it uses serverless, we don't have to worry about moving parts. We don't have to worry about how to set up sharding. We don't have to worry about running out of storage space. We don't have to worry about upgrading instance types, choosing CPU and memory. It's very cost effective at scale. I'm not going to get into it on this talk, but this would be a whole talk on its own, but we'll do a little bit of pricing here so you have some idea. DynamoDB is highly performant at scale, so it guarantees data will be delivered in 1 second or less or your money back. Sounds like a pizza order. It's a little joke there. But really the performance you might get with DynamoDB is single-digit milliseconds for your queries. That's really, really low. Think like 3 milliseconds, 9 milliseconds. But the worst case, no matter the scale of your database, no matter how big it is, it's always going to be 1 second. And that is a hard guarantee for Postgres, but for DynamoDB, it's designed in that way to do so. So what does a DynamoDB table look like? Well, it looks just like a Postgres table, but some of the names are turned around. So tables are still tables, but rows are now items, columns are now attributes, your values, or like they'd probably be called cells, are now called values. So just a bit of renaming there. And so it looks like a relational table, except there's a couple things you can't do or you don't have. So you don't get joins, and that's a big one for everybody because they're so used to joins. And you don't get primitive data types. So let's talk about not having joins, because like that is the hardest thing for people to wrap their heads around with DynamoDB and why they quit. So I really want to help you through that. So how would we normally do this with SQL? So let's set up a scenario. Let's say we're building out a discussion forum. We have a post here. You can see that we have data in there. And we would want data that maybe looks like this. So we'd write our SQL query. And so here's our SQL query, grabbing data from the post table, the topics table, the forms table, the user table. Would take us like a minute to write that query for multiple tables. All right, so then how do we do with the DynamoDB if we don't have joins? Well, what we would do is we'd have to write API calls to all those tables and then assemble the data. So let's say we use Lambda functions because we're all about serverless. So we have a Lambda to get the posts, and then that passes the data on, and then we get our topics, and we get our form data, we get our user data, and then it takes all that data, passes it to a final Lambda that assembles the data that looks like that. And you're looking, holy moly, that must be a lot of work. Now, I just want to give you a sense of how much code you'd have to write. So over here, you'd use the DynamoDB SDK, because obviously we're not writing SQL queries. But here we'd have fetch our post, topic, form, user, and data. So it's not that bad. Once you start writing some DynamoDB SDK code, it becomes a bit of a habit. But if you have an existing app, so like example, we have hundreds of queries, like raw SQL queries, and to translate that over would be a lot of work. It's very intimidating. We would not be very happy as developers. So how can we get our developer happiness back and still use DynamoDB? Because we don't have queries. Is there some other kind of query language we can use? And that is the case. So AWS AppSync is a generic query adapter that will do the heavy lifting, so we don't have to write all that DynamoDB SDK code to fetch multiple DynamoDB tables. And so we get this query language. It's not SQL, but it's better than writing all that DynamoDB SDK code. And so with AppSync, you'll have your query, and that query is going to go to all those tables, grab all the stuff. Some will be in parallel, some will be sequential, and it will save us a lot of programming time. And if you're wondering, well, what exactly is this query language? Well, it's actually just GraphQL. If you haven't had a chance to use it, here it is. So GraphQL is an open source query language that can be used as a generic query adapter to fetch data from multiple different source databases. And you could use the same query language to fetch data from DynamoDB and Postgres. So if you still want to use DynamoDB and Postgres side by side, you could use AppSync and you could totally do that. And that could be a good migration path for you. So AppSync is really just a fully managed version of GraphQL with direct integrations to AWS services such as DynamoDB. So is that all there is to it? We're just gonna, if we just want to move over, we just got to use AppSync and move our tables over. Well, it's not exactly that. We can do that, and it works fine for smaller apps like 100 Days of Cloud, but we're not taking advantage of the full costs and savings that Promise deliver. And on Exam Pro, which is like an existing app, that's what we're looking for, right? So let's focus around the use case for that application. So for Exam Pro, we have 45 Postgres tables. Right now we run it at T2DB micro. I know it's super small, but we've really optimized that so we don't have to go larger. And that's $15 USD per month. So if we were to move all our tables one by one over to DynamoDB, or I guess all of them over, if we use the default setting, which is 5 RCUs and 5 WCUs, that's going to give us a calculated cost of $2.91. In DynamoDB, you have these RCUs, WCUs. You can say how fast, like how much capacity you want, like how many queries can you do at the same time, and have a guarantee per second. Okay. And so we calculate that out. We have 45 tables at $291. That's 130 USD dollars. And there's the CloudWatch alarm. So it's like 139. It's almost 140 bucks USD. And I'm in Canada, so that's expensive. So this is not really a fair comparison. I just wanted to point out that if you weren't paying attention and you made those tables, that's how expensive it would be. But we could probably, in my use case, tweak them down to 1 RCUs, 1 WCUs, and tweak those tables based on their usage. And we're at $35. Still more expensive than an RDS instance, but it's $35. I don't know if there's a free tier. Maybe the free tier factors into that. It'd be more cost effective. There probably is, but I just wanted to give you a comparison without free tier here. There are other hidden costs. So Postgres databases with startups, they generally they'll utilize them for full text search, active analytics. There's a lot of Postgres extensions you can install. So you might have to build those out, not in DynamoDB, but in other AWS services. So that's a hidden cost doing your migration over. There is a mode called on demand. So instead of paying a fixed rate, so you see 5 RCUs and 5 WCUs, you just pay for what you use. I've not been able to Google a real world pricing example. I'd be very afraid to move over my 45 tables and then discover the cost. So if you're building a small app on demand and then you grew with it, you would understand the cost, but I don't have any sense of it and nobody's telling us. So just be aware of that, that if you have an existing app, you might not want to do on demand. So we talked about cost. Let's talk about performance. So we saw cost for multi-table for existing app wasn't the greatest. What about for performance? So we said that DynamoDB can return a query in single-digit milliseconds, and at worst case is 1 second. So let's do the best use case, saying we're all getting those back in single digits. Remember when we set up without AppSync, we set up with all those lambdas? Well, we'd have to consider those cold starts. We'd have to consider the API calls. Some of the requests might not be parallelized. And so what we think we're getting, so we think of all those millisecond requests. So we're thinking like, okay, it's going to be like that fast, 25 milliseconds. But when we factor in all these additional layers of technology that have to do communication, we're really getting something that's a lot slower. And this is like a good use case. This might be like 3-4 seconds. Now, depending on your app, it might not be a big deal, but you always want something under like 500 milliseconds or 300 milliseconds. Depends on you. It's not that bad, but it's still like we really want performance. So, and just consider that for lambdas, it's usually between 100 and 300 milliseconds. It's okay. We could bring this down with AWS AppSync. So using AppSync, they have built-in cache. So that would cache the common requests. Or if we're using pure lambdas, we could use provision lambdas. There'd be an extra cost to it, but it would shave off all those cold starts. But just realize that optimally, multi-tables aren't the most optimal design that we could have. So how could we get the overall performance and cost that we want? And the issue really comes down to the fact that we're using multiple tables. If we had fewer tables, right, there'd be fewer calls. There would just be fewer costs per table. So is there a way that we can put our tables into our tables? Okay, and this is what I call tableception. That's a meme from Inception. So we're talking about going deeper. How do we put tables into tables? Is it even possible? And it is. We totally can. So what we could do is we could just take all the data we need from our tables, right? So here's our tables. And then we could just move them into a new table called topic post. And that would just be for that single data access pattern. Remember we had that post here? That's a data access pattern. That's a single way of viewing data that is formatted. But the only issue is that what happens when we have multiple data access patterns? Because clearly an app can't just be that one post. So maybe we're listing forms, listing topics. We did the one there. So what about data that's like our email up here, right? Because if we made this new table, we're not eliminating these old tables. This data might be used in other places. And what's what we want to do. We want to reduce the amount of tables. Sure, we're getting performance here, but let's reduce the cost as well. So that's what we're going to look at next. So how could we take all those data access patterns for different pages and put them into a single table? Is it even possible? I'm going to tell you it is, okay? It's possible to take our data access patterns, so like listing forms, et cetera, and have one table that powers it all. And just before we jump forward here, I just want to make sure you know what a data access pattern is, because it is a new term that you might not be familiar with. So think of what data we need to display on different pages, including how data could vary based on sorting, filtering, pagination. That is what a data access pattern is. So let's go deeper. So how do we put multiple data access patterns into a single table? Well, DynamoDB, like you can't do this really well with SQL, but you can do it with DynamoDB because it's schemaless. Okay, it means that we can add or remove columns without much concern, because we're not conformed to a very strict schema. Now, we still have to design our schemas up front, but the point is that we can mix and match stuff, okay? And so what we can do is we could just have each row be a different data access pattern for different pages. So what we'd have maybe is more like a generic name for a table, like discussions, to power all the discussion features, or all the discussion pages. And for listing topic post, we'd have an item, and that'd be all the data that we would take for that. Then we'd have one for the forms index. We'd have one for when you click into a form and you have the topics. And so the idea here is that we have all these rows, and this is me like lifting them directly from our Postgres table and putting it into a single table. But the only issue is, like, and I don't know if you noticed, but how do we actually query and get out the individual rows for the different data access pattern use cases? Because if you look at the IDs, they all have IDs, right? So that's not going to work, right? We can't just have name all IDs, because how are you going to tell which is for which data access pattern? And so that's where designing your primary key, your key in DynamoDB becomes extremely important. So now we really got to talk about how are we going to design our primary key. And I'm just doing a little bit of theory here about primary keys because it's so important to DynamoDB. But when you create a table in DynamoDB, you have to define a primary key. And the primary key determines where and how your data will be stored in partitions. So the primary key cannot be changed later, so we have to be very serious about our architecture of this key. And we have two options here. We set a partition key and a sort key. And we can have one, and we can have just the partition key, or we can have both. And depending on what we do is going to determine what kind of design we have. So the partition key determines what partition things are written to, and the sort key determines how we should sort keys on a partition. Again, don't worry about partitions for this talk. I have a lot of data, or I have a lot of videos on that somewhere else you can watch on. But I just want you to clearly understand that if you only use a partition key, we call it a simple primary key. And if you only use a partition, or if you use both the partition sort key, it's called a composite. And we'll talk about that here right now. So again, if you're only using partition, it's simple. If it's both, it's a composite. And the way that would look is like if you were designing a simple primary key, you have to have a single column, and the values have to be different. As you saw when we pulled over our rows from different tables from our Postgres, they might have overlapping numbers, right? You might have a user that's 4 and a post that is 4. So maybe a simple primary key is not in the cards for us, or we'd have to do some kind of other way to make them distinct. And then a composite key would be like you can have your primary key or partition key is the same, but at least the combination of them are different. Okay. So I'm not going to get too much into that, but I just want you to know that there are two different ways of doing it. And so how would we design this for our use case? Well, this is the most simplest use case I could show you, but imagine we just prefixed each one with the data access pattern. So for topic post, it's TP. For form index, it's FI. And for form topics, it's FT. And so this is a very simple use case to get our data. But really, like, the topics of designing a key, like, literally could be its own talk. So when you are looking to move from Postgres over to DynamoDB, just search, and you want to use single table design, just search single table design primary key DynamoDB, because it's so complicated, the story. But once you get over this hump, it's a lot easier. But remember that we had that users table, right? And I'm showing you here just the discussions form. So we still have other data. We got to put it somewhere. So where's it going to go, right? And so that's the question is, where does our data live in a single table world? okay? And this is where we talk about domains. So on the left-hand side here, we have a bunch of pages that are related to the discussions, right? And so it was very easy to name a table called discussions. And so most data access patterns will fit into that table. And so that's the discussions domain. And then on the right-hand side here, maybe we have like the user's profile, like the login, the account, and we have a users table. Maybe it could be a single table there, and that's the users domain. And so what's interesting about this is that you could build out AWS Amplify apps that take care of just these pages, and they have just a single table, right? You might have multiple tables depending on your use case, or you might have extra things to do that. But generally, this is the concept I want you to leave you with is like, imagine you're taking a table for a bunch of pages and slamming them into one table. And so that is the idea behind single table design. And that is the idea of how we're going to get our performance and costs for the Exam Pro side. And that's what we're doing. So should we always use single table design? Well, no. And it really depends on who you talk to. If you talk to the Dynamo DB team, they're going to recommend single table design. If you're talking to the AWS Amplify team, they're going to recommend multi-table design. It just leaves you a little bit confused. So when should you use which table design? And this really comes down to just being like how people perceive it. And so if you are in the NoSQL world and you're very serious about it, this is your view. Like single table design is way more powerful than that. But to me, that's not really the case. Okay, there's definitely a clear difference between the use cases. Let's go to that right now. So between multi-table versus single table design, it really comes down to your use case. So with 100 Days of Cloud, we're using multi-table, and with Exam Pro, we're using single table design. So and the reason why is that when you have very few tables, you can afford to be less cost effective and have more of that experience that you're used to using with SQL. So you have more agility. On the Exam Pro side here, when you want to optimize your database for cost and performance for the best possible offering, and you're just designing your thing for the last use case that'll ever be used, then it's great for that. When you have yet to settle on the final data access patterns and expect many changes, multi-table design gives you a bit more flexibility. And if you, on the Exam Pro side here, when you're using single table design, you know exactly your feature set. You don't expect many changes, and so you're ready to scale. When simplicity and developer agility is more important, use multi-table. When you can handle greater complexity and less developer agility, use single table. And I want you to know that you can use both types of table designs in a single app. You don't have to use just one, and you can always migrate from one or another. So if 100 Days of Cloud gets bigger and better, we'll just move those tables over to single table design when need be. But I just want to show you that like there's a lot of flexibility there. And it kind of contradicts what we said earlier between SQL versus DynamoDB at the beginning, where we said DynamoDB wasn't flexible. And there is some truth that it isn't flexible, but clearly there is some flexibility with DynamoDB. Now, I just want to leave you some more resources because, again, I'm just covering the level 100 here, the foundational information that I want you to know. So if you want to go a bit deeper, I recommend checking out Alex Debris' book called the DynamoDB book, where he is showing you how to design tables for all like one-to-many, many-to-many, and a bunch of the other scenarios that you'll need. The book does cost money. He does have some good articles that you could read, so if you need to try to go a bit free there, you could do that. But the basic book is $79 USD, and then it goes up in price. They have a few different tiers there. If you're looking for a free resource and you're just something very practical to get started, Marcia has a very, very, very good video on single table design, and she does a trial and error through it. So like I'm showing you a very simplistic view of how to design a table, but she actually shows you like in practicality, because you might have to add GSIs or LSIs or change things around and redesign your table a few times. So she really shows you that well. If you're looking for just more DynamoDB knowledge, Exam Pro, like it's a paid platform, but all my videos are free. And for the developer associate, I have a huge, huge section on DynamoDB. I have 1.5 hours of video. They're all broken down. You see they're really small videos, and they're broken down to pretty much cover everything in DynamoDB. And there is some practical scenarios there. So if you really want to get through it as quickly as possible, you can do that. And you can just go on my site there and press the watch button and watch them for free. And if you're just looking for some challenges, let's say you are just trying to learn and you want to work with a community of like-minded people, you're new to cloud, you can go check out 100 Days of Cloud. And we have a repo called 100 Days of Cloud, 100 Cloud Ideas. And these are just micro projects to get you like thinking about what you could do. So we have one on like designing a single table, multi-table, using DynamoDB with Amplify, create a DynamoDB that has a cache column for counting. So there you go. So hopefully I've left you thinking about how you can use DynamoDB, and it's a little bit less scarier with AWS Amplify. And so we'll just move on to questions now.